analyzing a reciprocal function. Uh, so in this, looking at this for Ohm's law, we have our equation for electrical current I, and then we have uh, our volts in V, and then our resistance in R. Okay, and we want to analyze what this would look like. So here we're talking about our equation, just like Y equals 1 over K. And so what can we not plug in for the denominator there? That would be 0. So that's why we have a vertical asymptote. A vertical asymptote at x equals 0, or for r's would be r equals 0. Okay, and then the top one is there anything being added to this at the end? Is there anything being added after the fraction? No, there's not. So that means we have a horizontal asymptote at y equals 0. Or for r's, I guess it would be I equals 0. Okay, and so analyzing this, we can see, of course, it doesn't cross the x-intercepts. We could also plug in numbers and get in our points, kind of like we did on number 2, just graphing it, plugging in numbers, seeing what we get. But we always want to balance out what makes our denominator 0, and then we can start plugging in numbers from there. Okay, so then analyzing this, we can see the domain is everything but r not equal to 0, right? And then our range is y values going from the bottom and going upwards this way, but we know we can't get this 0 value, right? And then after that, we can keep on getting y values. So our range, this is our domain, and our range is all y values, right? So all y values except for our i's cannot be 0. So you notice that has to do with your horizontal asymptote there. Okay, and then we can see we have positive numbers. Our graph is positive when we are right in this section right here. We can see this branch right here. All our numbers are positive. So all our numbers are positive when our r's are past 0, right? When we go this way. So when our r's are greater than 0, we have positive answers, positive current. And then we can see we have negative current right here. All these y values are negative, or I values are negative, when our R values are negative. So when our resistance is negative, or so when our resistance is negative or less than 0, we see our current is negative. Okay, and then we could look at end behavior. Right, so looking at end behavior a few different ways. Okay, one, as we go to the right, as our resistance increases. So as R goes to the right, to positive infinity, what does the y value do? It's get closer and closer to 0. Then I value gets closer and closer to 0. But when my resistance gets closer to 0, so when I get closer this way to 0, but from the right side, what does my I do? My I goes up, up, and up. All right, so positive infinity. And then I can look at this branch and say, okay, as I go towards negative infinity, as my resistance goes towards negative infinity, my current goes closer and closer to 0. So current goes closer and closer to 0. And then I can see as I get closer and closer to 0, but from the left, as my R gets closer and closer to 0 from the left, my current, oops, I guess I put that in there, goes which way? This one goes down, so negative infinity. And so that would kind of be our end behavior there to represent that. And that's how I can describe the key features. What makes the denominator 0? Your vertical asymptote. Is there anything being added to the fraction afterwards? Your horizontal asymptote. And then you can do your end behavior.